Hello everybody, I'm going to run through a refactoring for some real code at work. Here's a little piece of code, test for a piece of code that activates some neopixels to show whether a phone booth is available or occupied. If the phone booth is available, we expect all the neopixels in the indicator to be flashed to green. Otherwise, if it's occupied, we expect it to be red. Here is the code. So we wrap a neopixel object. Then when we update the color, if it's available, we call the show color method passing in green. Otherwise, we pass in red. Back to the test. The approach for the test is to use PyTest, create a fixture that will create a neopixel booth availability indicator, which is the thing under test. And we also have a fixture that mocks stuff. So by mocking, what we do is the class under test, the show color method becomes patched. So basically what we're doing is testing a partial mock. So when we pass available to the update color method, we expect that we're going to call show color with green. And similarly, when we call update color with occupied, we expect to make the same call passing in red. Two problems with using a partial mock for testing. One of them is, well, let me run this test real quick, make sure that it actually runs green. There we go, green. So what I can do is modify and even delete the show color method. Well, I have to at least have a pass. And see what that does to our test. Okay, now we've broken the code, but the test is still green. That's bad. But it gets worse. What I can do is, I know this neopixel library has a fill function that basically does exactly what this loop does. So what I can do is, instead of self show color, I can do a self.neopixel.fill with green, and then similarly, those are my birds, neopixel.fill red. The only other thing I do is whenever I call this, I have to ask the neopixels to write their current value to the hardware. So I'll add it right here. Okay, so this is a refactor that's perfectly valid. Now I've got working code and a broken test because the test was dependent on update color calling the show color method, and I'm no longer doing that. So let me revert this code and we'll rewrite the test a different way where we're using emulated hardware rather than a partial mock. Okay, revert that bit. Back to the test. Let's make sure everything is still green. And indeed it is. So I want to completely get rid of this PyTest fixture. And I want to have some other assertion here. So I'll just skinny this down. Now what I have should be a green test, but I'm not actually asserting anything. So those assertions need to be added to make it an honest test. So when I call NeoPixel update color, that is wrapping a NeoPixel strand. So I can grab that instance. And I've got this writes for testing object. Because what I've done, if I look at my requirements txt, is I've included this ESP32 machine emulator package, module rather. And one of the things that it does is that it emulates NeoPixels. So now that I've got an emulated NeoPixel, I've got all of these for testing methods. So yeah, that statement doesn't have any effect because I'm not doing anything with it, so I'll just assign it to some variable name. Okay. So that is a list. So one thing I'm expecting is if I'm writing the NeoPixel, I'm going to expect that I have one right. So let's try that. Assert length of A is equal to 1. And that's green. And just to make sure that it's possible to get a red test, let's duplicate this call where I'm making the call twice. Now I get a failure because I expected one right, but I actually got two. So that's good. So that's a good test, but not particularly, well, it's not a good test, it's a crappy test. Because all it verifies is that update color writes. I want to know that it's actually writing green. So I'm going to make an ugly variable name. So b equals a sub 0, which is our first thing. So what type is b? What can I do with a b? This is not helping me. So I can look into the actual NeoPixel code. Writes for testing is an array, and I'm appending the self current pixel colors, which is a type of strand history for testing. Strand history gives me a time from first write, and I also get a color list. So let's grab that color list and see what we can do with that. Okay, I'll call that C. So I'm deliberately writing a bad test one step at a time because I know that I'm going to clean it up at the end. So now I'm going to expect that that color list is all green pixels. So I'm going to say assert C equals a green tuple is going to be red is 0, green is 255, and blue is 0. Double equals. Let's see what that does. Oh, actual is 0. Oh, very good, because when this was first written, because of the partial mock, we didn't actually need this to do anything. We didn't need the init to actually assign any NeoPixels. So I'm going to use named parameters instead of positional parameters. So the first argument is the pin. The second one is the number of pixels or something like that. Yeah, num pixels equals 0. So if I have zeros when I write, I'm going to write nothing. So I'm going to set my number of pixels to 3 and see what that does. Now, what I forgot to do is make this a list of 3. So I'm going to do that right now. So what's this going to do? Hopefully it's green, and indeed it is. Let's make sure this can possibly go red. So I'm going to change my green value. And indeed it did go red because, oh, interesting, I got my expected and actual backwards. No, I didn't. I got it right. So I expected 254 for green, and I actually got 255, which is the correct value. So I'm going to make this green. And now I'm going to clean up my code. I'm going to refactor, rename, Shift F6. A is really rights, I guess. Pixel rights. I'm going to use an idiomatic Python name. I typically use idiomatic C names. Okay, very good. So B is my pixel rights. That's not particularly useful. And I forget the key for inlining, so I'm going to inline that bit. So I've got a color list. I don't really like the variable name C, so I'm going to spell that out. Color list. So I'm going to expect that my color list is all green. So that looks pretty good. So now I'm going to do the same thing with red. With occupied. So I'm going to expect my green is 0 and my red is 255. And that test pass. Now back to my production code. What I wanted to do, but it broke my test, is I wanted to get rid of this loop and instead use the method that's built in, the fill method. So I'm going to get rid of that function, do my right at the end. I'm going to do a self dot neopixel.fill green and a self dot neopixel.fill red. Run that. Very good. So now, because I didn't change functionality and my test is only testing functionality, not implementation, I'm free to refactor without breaking my tests. So I can refactor and clean up the code under test, the safety of tests. I could probably clean this up a bit. How about I copy this block and make some kind of function called def is one right with color. And I want to take the color as a parameter. And I'm also going to want my neopixel indicator as a parameter. Grab that. I could use refactoring tools to extract a method. I'm just doing it the long way. So basically, now instead of my assert, if the length is not equal to 1, then I want to print expected one right, found, oh, forgot my beginning double quote, whatever length pixel rights is. Okay, and then I want to return false. Then I'm going to check. Now this is actually a color list, so I'm going to rename that variable. That since it's not used, I'll just rename it without refactoring. So I want to insert. Oops, this is expected color list. So I want to assert that my actual color list is equal to my expected color list. Okay. So now I should be able to sub out the lines of code here. Assert is one right with, I didn't quite finish my code at the bottom, but I'll do that later. Passing in my NeoPixel indicator, and my expected color is going to be this list here. Yeah. So basically what I have here is a tuple of color green wrapped inside of a list, and I'm multiplying that list by 3 to get a single list of 3 tuples. If that makes sense, hopefully it does. Okay, then I can delete all that code. I could get brave and do red, but I'm going to be cautious. And the code that I forgot to finish writing is if my color list is not equal to the expected color list, I want to print I'll just kind of cheat and do a real simple message. I want it to be a much better message. Actually, no, I'm not going to cheat. Expected colors, expected color list. And I found the actual color list. And now I want to return false. Okay. And hopefully I'm still... Oh, I messed up. Assert none where none equals... What did I do wrong? Don't panic, Todd. Assert none where none is... Oh, stupid. Return true. A mind is a terrible thing. Here we go. Now I'm green. Very good. So hopefully I'm green for good reason. Let's make the list size different. Make sure that I can get that red. Indeed it is. It says my assertions failed. Oh, I expected these colors, and I found these colors. Oh, right. That's exactly correct. Yep, so that's good. So I'll put that back. Now I want to break the code the other way by having more than one right. Since I'm expecting one right, if I have 2 rights, the test should also fail. Or if I have 0 rights. And indeed, it fails. Expected 1 right, found 2. All right, so now I've got a nice refactored test method. Make sure I'm green again. Yeah, I don't really need that extra space. And I can sub out these lines of code with a test for red instead of green. Run. Very good. So the lesson here is be wary of mocks, especially when mocks are testing code that you've written. Mocks are useful for testing system boundaries. If you're calling a external API, a web service, or a database, it'll make sense to mock that behavior. Otherwise, if it's your code, you're probably going to run into situations like we did with this code where the mocks not only don't serve to protect your code, but it also hampers you to be able to refactor and redesign your code. Hopefully this is useful to you. Take care.